Before getting into the final project issues and today's lecture, I like to see some type of experience you gained last week. This is the last week's one of the lab exercises. Try to design and print. So I asked you some 3D printing from this 3D Max geometry, convert into OBJ file and G-code generator. At this time, Simplify 3D, you experienced how to make support and geometry control and simulate before actual 3D print, something like this. And this model, also 3D Max model, but turn into the OBJ file as well as G-code file in order to print something like this. So let me show you some examples, okay? Other class example, something like this, okay? Small feature, small geometry, but it's looking okay, right? Another example, inside of this object is empty, void. If you feel a lot of support, there is no way to get rid of inside the support. Take a look. Lots of support structure, but it's not easy to take this out because it's not that strong. So this one might be broken. Anyway, even if there are amount of support structure, but anyway, it's looking fine. And one of the students printed her chair design. Actually, he told me this is designer chair. It's a copy, but anyway, very simple geometry, but easy to print and looking okay. Rose shape, but some supports still there. But anyway, some type of organic shape. Another one, okay. She told me that this is a keychain, key ring, something like that. Or another cell phone key holder using this lion, okay? Name, also 3D name printed on the surface of this 3D printout, and strawberry shape for her own keyring or something. And one part of the chair geometry and laser scanned face also printed out. Okay, let's go back to the course material. Why some failed in 3D printing? You just saw lots of cases. I show you pictures and live pictures from you guys, okay? Someone made very, very sophisticated and fine-grained, higher resolution product, and someone failed in removing support and in its geometric shape and so on. Why some failed in 3D printing? So as you remember, we have learned what is surface-based 3D model and solid 3D model. 3D Max, Rhino, SketchUp, all they are surface-based 3D model. What is surface? This is surface and the controlling of the surface. Take a look. This one is another type of surface. The definition of surface is conceptual, mathematical, which has zero thickness, okay? No thickness. In real world, there is no such object. There is no line, no point, no surface, okay? But they are very, very nice to visualize, okay? Any type of 3D objects can be visualized thanks to this surface-based 3D modeler, okay? But actually, in real world, we need solid 3D model. Surface doesn't have thickness. Thickness is zero. So how to print that surface in 3D printers? But if it has thickness, solid 3D model, like Revit, ArchiCAD, most of BIM tools support solid 3D model. So a solid model is an unambiguous computer representation of a physical solid object. Physical solid object is the keyword. Your 3D printout is physical solid object, not computer model. So take a look, non-solid model, surfaces, okay? They cannot be printed because they are zero thickness surface. How to print which one has thickness is 0. There is no way, okay? How about this one? Those two are okay, but the connection part and this dangled surface is problem. No way to print out. How about this one? Reduce maximum, but minimized and reduced 0, which means line. We can see line, but line doesn't have a thickness. So how to print this line? So this is another problem. Klein's bottle is famous. 3D version of Möbius string. There is no inside outside. Okay? There is no inside and outside. Take a look. The inside going to be outside. Something iteration, infinite iteration, inside and outside. So they are problem of surface-based 3D model. So get rid of those problems. That is physical solid 3D. Why we need a solid model? First one, it's another famous devil's poke. This one is invalid. This is track, a fake. Okay? How about this one? This one can be this one. You can easily imagine the shape of this one is looking like this. But think about those two are the same wireframe. Okay? So this one can be any one of them. That's the problem, ambiguous. Okay? So get rid of this invalid, ill-defined, or ambiguous, or some surface 3D. Inside is originally hollow. Okay? In 3D Max, this geometry inside of this cube shape and this cylinder shape, they are all empty. Okay? Inside is hollow. But thanks to this G-code generator, simplified 3D, solid 3D model converted by 3D printing tool. Okay? When you create G-code, take a look. Inside has autofill. Okay? Actually not 100%. If you fill the inside of the structure 100% of the material, your product is too heavy and printing time is too long, material cost expensive. Okay? So 50%, 40%, you have option. You can control. Okay? So autofill inside, that's the feature we can take advantages of that kind of tool. But when I use this kind of 3D printing tool around 10 years ago at Georgia Tech, at that time I couldn't print this out in general 3D printers at that time because there is no this kind of functionality. Autofill of inside, okay? We have to use solid 3D modeler, not this kind of surface-based 3D modeler. But nowadays, you are free to free to design by this kind of surface-based 3D tool, and you can print this out without problem. But sometimes you have problem when this surface polygon is open, enclosed, not enclosed, and then geometry has problem. Okay, there is no way to fill inside because of that hollow hole. Okay, so if you have this kind of problematic geometry, some problems in your geometry, your outputs can be failure. Okay, something like this. There is no way print this out, this kind of surface structure, ill-defined structure, ambiguous structure, or something beyond the 3D printer's capacity. What I mean is, if it's too thin or too narrow, too small, the resolution of the 3D printer has its limit. Okay, it's not easy to print out very, very small and thin object. So you need to control the scale, size, thickness, and so on. They are all cannot be printed. Okay. Hopefully you, based upon the lab exercise from the last week, actual printout, you experience the relationship, correlationship between your computer model and actual printout. Okay, so I show you live demo, live pictures. Some of you got very successful geometry, totally same from your original geometry in 3D Max and your outputs exactly same, but someone has something wrong, something changed. There was some problems in removing support or something else. Some unnecessary and unexpected problems you encountered, you experienced. So to resolve such problem is the subject further work, okay? That's why I gave you that assignment, that lab exercise, 3D print. So surface-based 3D is not good? No, still it is very effective and powerful. I told you, again, Surface 3D model, 3D Max, Rhino, SketchUp, Maya, any other general type of 3D modelers are very good to visualize, okay? Surface modeling is very good to visualize any type of 3D objects, not only in the real world, but also in the cyberspaces, like game environment. That's why I show you several different approaches. First one is just make a box, and inside of the box can be your building interior. So a fake model you can make only for visualization purpose. But today, last week, we made walls, window. Today we're gonna make windows, stairs, and doors. Physically looking objects, okay, columns and so on. Later on, we're gonna make some building model using BIM tools, Revit, and so on. So when you need only visualization, you need to take advantage of surface-based model and its visualization. You don't need to make entire world, okay? That's why your universe of this course, defining UOD is the most critical when you get started with your design, modeling, and visualization, rendering, and so on. Anyway, the topic for the class this semester is visualization. That's why we are dealing with surface-based 3D model. But later on, we're going to deal with some examples in BIM tool, Revit. So you need to figure out what is the main difference between those different type of applications.